So now we're going to determine if the following equation is a function of x. We're going to look at y equals 1/2 x plus 3. Now notice that the key word here is function of x. A function of x means that x is the independent variable or the input. So we can have functions of many variables. They can be functions of y, functions of t, functions of r. Most of the time when we have a y equals equation, we're going to look at functions of x. In order to determine if the equation y equals 1/2 x plus 3 is a function or not, we can use a table of values, we can use a graph, and once we get good at it, sometimes we can tell just by analyzing the equation itself. Today we're going to use a table of values. So to make a table of values, we're going to set up a table where we're going to have the x's on one side and our y values on the other. Now notice how I put the actual equation in for the y values instead of y. That's because remember the x values, when we're looking at a function of x, are our inputs. In this case, I'm going to input 0. And the y values, what we're returned by plugging in the inputs, are called the outputs. So we have to plug the inputs into the equation to get that y value. So that's why I have the equation up there, but you can put y up there as well. Now that we know we're going to look for our outputs, we're going to start by plugging our chosen input, in this case 0 is really easy, into the equation. Notice how the x, or the 0 in the x component, turned red, and in the equation in the bottom right there, I made the 0 red. So I replaced the x in our equation with that 0. Now we're just going to go ahead and do the math. First we're going to start by 1/2 times 0, which is 0. Bring down the plus 3, and now we can add 3 to that to get y equals 3. Once we solve for y, we're going to plug that value into the corresponding spot in the table. So we chose 0, we plugged 0 into the equation, we solved for y, or we did the calculations, and we got y equals 3 and plugged that into the table. Now I want you to pause the video and choose 2 more values for x and fill out the rest of this table. Remember, for this to be a function, we're looking for every one of the inputs that we plug in to return only one value. It doesn't matter if those values are the same. And this equation is linear, so hopefully they're not the same. But remember, you can have multiple outputs, but you can't have one single input resulting into more than one output. So if I chose another number for x in here, like 1, and it also returned 3, that's not so much a big deal as if 0 returning 3 and a different number. Now while you finish the graph, we're going to go ahead and move over to a graphing application called Desmos so we can fill in the table ourselves, plus look at it graphically. So looking at Desmos here, you can see in the top left corner I have my equation x, and or my table of values, x on one side, my inputs, and the 1/2 x plus 3 on the other side. I can plug in values for this. So we chose 0, so I'm going to plug in 0 here, and if you notice, a 3 returned on this side. I'm going to do the same thing. I can zoom in a little bit for you. I'm going to do the same thing for some more values. And your values don't have to be positive, nor do they have to necessarily go in order when we're doing our table of values. So let's say we want our next value to be 1. If I plug a 1 there, you see that I get a 3.5 out here. Now zoom it out on my graph, you can see the points appear. Here's 0, 3, here's 1, and 3.5. Now, when you're doing calculations, especially if you're going to use this method for graphing in the future, it helps to choose values that get whole numbers if we can. So we notice that the bottom of this is a 2, so any multiples of 2 will make this fraction turn into a whole number after we do multiplication. So when I choose 2, I should get a whole number answer, which I did is 4, and you notice how the point appeared to 4. Let's try some negative numbers as well. So let's go -1. And let's go -2. So you can see I chose my values for x. Each value of x is returning only a single output, and they're falling on this graph just fine. And we can also look, remember x is our domain. So if I look along the x-axis, and I notice that for every value along the x-axis, I can trace this up and find only one point on the graph for that value of x. In this case, we chose these specific values, where these points are -2, 2, -1, 2.5, 0, 3, 1, 3.5, and 2, 4. But I could come out here to 4, and I can trace that up as well to this point here, and find out what that is. We can come over to our chart, type in 4, and that's going to be 4, 5. We could have also found that from the graph by tracing this over to see that this is the 5 area. So in conclusion, because each input had exactly one output, this equation, y equals 1/2 x plus 3, is a function.